So the next presentation is from Costa about Netdata, an open source distributed observability pipeline, a journey and challenges. Applause.
Hello guys. So how many people use Netdata in this room? Oh, a lot. Okay. So guys, I have to admit something. When I get pissed off, I write code. I know others go to the gym, but for me, this is how this thing was born, actually. So I was migrating some infrastructure from on-prem to the cloud, to one provider, it doesn't matter, and we had a lot of problems. It turned to be cloud provider bugs, not our bugs. But after spending a couple of million euros in observability, building a team of 8 people, installing every tool that exists out there, this was back in 2014, I concluded that everything that I had built, I was a C-level executive back then to a fintech company, I concluded that everything that I had built is an illusion. So the entire everything, every observability tool that I tried, is an illusion. It's there to make me feel happy. It doesn't actually troubleshoot anything. So I started thinking, okay, why they did it like that? Why they are not real time? Why cardinality or granularity is such a problem? Why you have to set up everything bit by bit? You need months and months of preparation in actually to build something useful. And I started experimenting. I started writing code to see, can it be done differently and what this different would look like. So I started with the first commit in 2014, it's in 2014, it's on GitHub. After a couple of years of experimentation, I released it and boom, people loved it. So what is Netdata today? Today, Netdata is a monitoring tool that you install on a server, and it's a monitoring in a box. So it has all the functions of a monitoring pipeline. It discovers metrics, collects metrics, stores metrics, machine learning for metrics to learn their behavior, alerts, health checks for metrics. It exports metrics to other time series databases. It streams metrics and replicates metrics between the data agents. Of course, visualizes, query engines, everything. So it's an application you install on all your servers, and each application is a monitoring. So if you install Netdata today on an empty VM, you just go to AWS, get an empty VM, and install Netdata. What you are going to get? We're going to get this: 200 dashboard charts, 2,000 unique time series, 5 unique alerts monitoring, more than 100 components. As a viewer, as a logs explorer for systemd journal, a network explorer for all your connections, unsupervised anomaly detection for everything, so it will learn the behavior and trigger anomalies, detect outliers. You are going to get about 2 months of retention using half a gigabyte of disk space, and all of these run with 1% CPU of a single core, 120 megabytes RAM, and almost no disk I/O. Now, when you install an agent, you understand that since each one of them is standalone, you have to switch, go one by one to see what's happening. But then we build this. So the same software can become a parent. So when it becomes a parent, it's easy. You go to the others and say, stream there. And you give the IP of the other thing and an API token. So the moment this happens, the parent now can provide alarms, machine learning, dashboards, and everything for all the infrastructure that it is behind it. But we didn't stop there. You can have as many layers as you want of this. So you can have data centers that they have a parent cluster, and then regions, Europe or something that has another cluster of parents, etc., etc. This scales well. So we tested Netdata parent with 500 nodes and 40,000 containers against Prometheus. We did the same with Prometheus in parallel. Netdata used 1/3 less CPU, half the memory, 10% less bandwidth, almost no disk I/O, and in the same storage footprint, we gave them 3 terabytes, we managed to have up more than a year of retention. More than a year of retention. Of course, it is in tiers. Now, in December, the University of Amsterdam did a research about the most energy-efficient tool. They tested, of course, Prometheus, Netdata, etc. Netdata, they said, being the most energy-efficient tool. And what happens in CNCF? Netdata actually leads the observability category in CNCF in terms of users' love. Actually, we don't want to incubate in CNCF because of their policies. We believe that Netdata should be something different. So we never applied. So to build this, we had a number of challenges. The first challenge is that we wanted everyone using Netdata to be from 0 to hero today. So you don't have observability, that's okay. You install Netdata and you have observability today. How we did that? The first is an observation that we all have the same kind of infrastructure. It's a finite set. We use some virtual servers or physical servers. We use packaged applications, databases, web servers, message brokers. All these are standard components. We use similar disks, similar network interface. Everything is similar. Of course, the Lego we built is different. Each company is unique. But the components are pretty much the same. So what will happen if we start monitoring the components? What will happen if the monitoring solution knows when a Postgres is healthy, knows when a Kafka is healthy, when an Nginx, an HA proxy? What if the monitoring system itself knows if the networking stack of this Linux is okay? And how to monitor it, and how to present it, and how to visualize it. So the observation that we have a lot of common actually allowed us to think a little bit different. So how many of you work with Prometheus here? Okay. So you know the Prometheus, the open metrics format. So you have a metric, and then you have some labels, and a value that changes over time. That's the thing. What we did there is actually to say, wait a moment, not all labels are the same. The labels that depict, for example, that this is reads or writes on a disk I/O are not labels. They should not be labels. They should be something different. And we came up with this needle framework. This needle framework says that there is context. The context is the metric name in Prometheus, exactly the same, the metric name that has before the labels. We have instances. This does not exist in Prometheus. Instances are all the labels except the ones that get time series values. So if you have, if we're discussing about disks, is the make of the disk, the type of the disk, the serial number of the disk. All these are labels to enrich an instance. The reads and writes of its performance are time series. So what this allows us to do is the following. The first thing is that it allows us to go and configure dashboards at the context level. So we don't care about the metrics anymore. In order to provide a meaningful dashboard, we only care about the context. Then it allows us to configure alerts per context which are applied to all instances. So we can say, hey, apply this alert to all NVMe disks. apply this alert to all Postgres databases, or apply this alert to all Postgres databases before version X or Y. So the first thing is that this thing allowed us to have a fully automated visualization. You don't need to configure visualization with Netdata. It comes up. The same with alerts. They come up. We ship 344 of them. So the moment something happens, boom, an alert from Netdata will come up. I think this is not important. It's how, if you see it from the disk perspective, or from the container perspective, or from the database perspective, how the labels are matched, etc. It's not that important, and this is internal information for us. So this allowed us to have, as I said, fully automated all of this, and Netdata is the only monitoring tool that you can install mid-crisis. So you have an incident happening now, you don't have observability, you install Netdata, alarms will fire up. The dashboard will be there for you to investigate. The second challenge was, can we get rid of the query language for slicing and dicing the data? So in order to do this, we provide, you're going to come on a Netdata dashboard and suddenly you are going to see 2,000 metrics and you are not aware of them. You just installed it. So what can we do so that you can make sense of this? You can see the dashboard and say, okay, I understand what I need to do. So this is a Netdata chart. On the charts, we did the following. Of course, there is an info. What is this? But then we added a number of items on the chart to allow you slice and dice and see anomaly rates, make sense of that thing. Now, each menu that you see here has an analysis. And this analysis allows you to see, for example, for the nodes, allows you to see all this information that is described below from the same view. This is not another query. The biggest change that we did is that Netdata calculates this for every query, so it's a cube. Think of your data as a cube. You can see them in different ways. What we do is that we provide the time series for the view, for one of the views, one of the sides of the cube, but we calculate some numbers for every possible pivot that you can do. So that by just browsing the menu, you can understand, you can grasp what the data say. The same is with group by. So if you want to slice them, we do exactly the same. We give you all the possible options that you can slice by just dropping a drop-down menu, 2 clicks, boom, different cube, different view on the cube. And Netdata, and this is how the initial problem, do you remember that was the migration I had? The migration I had was that the bug at the service provider was that they were stopping the VMs to perform some of their updates. But they were stopping the VMs in little increments. So suddenly, one Friday, all the VMs were going in slow motion because they were stopping, starting, like this. With the data, I was able to find it because every data collection that is missed in the data is a gap. So it is not in the chart. Grafana, for example, and all the other tools smooth it out because there is no bit. In the data, there is a bit. I have to collect this every second. If I miss one, it's a gap. I didn't collect it. So another of the challenges, I am going fast because I have only 5 minutes, guys. Machine learning. Google in 2019 announced this. So they said, come on, we cannot make machine learning work for observability. So all our ideas are bad, and as they say, Todd says here, we should feel bad about it. So Netdata does the following. Trains, for every metric collected, trains 18 different models. These models cover the last few days of the metric behavior. Okay? So for the last few days, Netdata knows how the metric behaves with machine learning. Now, what we do is that every time that we get a new sample, we check these 18 models, and if all of them agree that this is an anomaly, we say, okay, this is an outlier, guys. This is an anomaly. Okay? 5 minutes, yeah, I know. Okay? So what this allows, I'm going fast. There is a scoring engine inside the data. So a scoring engine is an engine, you don't query for time series. You say, hey, I want to find the similarities in metrics. I want to know the trends in metrics. So can you score them all for me, please? All. It doesn't matter how many I have. So to give you an example, this is a data dashboard. There is a menu where we categorize everything. So it's an infinite scrolling dashboard, one chart below the other. Of course, there are many tabs with different views. And you press the AR button on the top right, and there is an anomaly rate on every section. So you can see now where your anomalies are. And we have a host level anomaly. So look what happens here. When anomalies happen in our systems, they happen in clusters. Look there, it's 5 nodes, it's 10 nodes. It happened together. Every line is a node. Look there. They happen together. And not only that, this shows the percentage of metrics in a node being anomalous together, concurrently. So you understand that Netdata can detect not only if a metric is anomalous, but here we can see that it can tell you the spread of the anomaly inside your systems, inside each system, etc. And then you highlight the area of interest. Netdata gives you a sorted list of all metrics that are anomalous within this region, this time frame. So the idea here is that your aha moment, oh, yeah, what? DNS did that? Storage did that? The aha moment to be on the top 20, 30 items. Another mission accomplished. 2 minutes, I know. Logs, I will pass through. Netdata is we base everything on systemd journal D. We had built our own logs management solution, like Loki and Elastic and the likes. We zipped it, how it's don't use it anymore. And what we do is we rely on systemd journal. Now, systemd journal has a lot of unique features, guys, especially if you are developers. The ability to index all fields independently of the cardinality. Independently. It doesn't matter. 1,000 fields, different values on every log line, indexed. Okay? This is unique. You can make troubleshooting amazing like this. We have a UI similar to Grafana, similar to Kibana, and actually, while all these tools you see on the screen, it's 15 million entries, below the title. 15 million entries, logs. All the others will sample 5,000 at the end. We stop sampling at 1 million. It's fast. We stop sampling at 1 million. We submitted patches to systemd to make it faster. We managed to bypass all the deficiencies of systemd for all systems. You will give me 2 minutes. Okay, because 50 seconds. I have another one. So, okay, we did a lot of work. We provided a tool, look to journal, that can be used to feed to systemd journal your HA proxy logs, your engine logs, or whatever, log FMP logs. If you have a Go application, they look like this. Boom, push it everything in. And of course, there is a weakness in the systemd journal, and this is mainly because it's reliable, it's fault tolerant. This is what it has been designed. It's secure, so it seals the logs. They cannot be tampered, etc. The key problem is the disk storage space that it needs. It needs a lot more compared to Loki or, I don't know, with Elastic, but for Loki that we tested, 10 times more. And you can make it a little bit better, 4 times more if you use a compressed file system. So another mission accomplished. That's the last one. Wait, I didn't see what it was. Yes. And that's another beauty that Netdata provides. So observability is more, guys, than metrics, logs, and traces. So the moment you run some infrastructure and there is an issue, metrics, logs, and traces usually are not enough. You may want to see the slow queries the system has, a database has. You may want to see the sockets that an application is currently connected. You may want to see different kinds of data. Most of the observability solutions give up. They say, okay, open the console. What can we do? Go to the console and figure it out. What we did is this. So every data collection, this is a Netdata. It has plugins, data collection plugins. Every data collection plugin exposes functions. It says, hey, I am Postgres collector, and I can give you slow queries. Hey, I am a network viewer, and I can give you the list of sockets. So we built the protocol in such a way so that you are there. You go to the grandparent, and you ask for something from this node, this function to be run. It does. So actually the whole logging system that we have, systemd journal, is built like this. There is a systemd journal plugin there that exposes logs. And this is a network viewer. What we did here is very simple. You have sockets. As you can see, it's 30,000, 31,000 TCP4 sockets. The key problem was how to make sense. So what we said, it's okay. From there is the internet. From here are private IPs. Above are clients, down are servers. The position plays a role. So you can immediately see what connects to the internet. And this is live. So if this was not a screenshot and you SSH the server, you would see the SSHD, boom, moving. This is live. Okay, our monetization strategy, Netdata is open source. This is what we sell, just for clarity. So we sell infinite horizontal scalability. We sell role-based access, access from anywhere because it's on-prem and on-prem solution, mobile app for notifications, and dynamic configuration and persistent customizations that we have a SaaS offering that does it. Of course, the same SaaS offering is offered on-prem for a price. That's it. Thank you very much. Again. Questions?
Thanks, Costa. Do we have any questions here? No.
I think Netdata is fantastic. I've been using it for a while, and I really, really enjoy the experience. A while ago, I was working on a massive experiment. I had 700 machines that had to throw gigabytes of information. So I started to look at Netd, and I basically went to the grandfather solution, and then the monitoring was something that wasn't there. I mean, it's a SaaS service. It's not open source, that part. Do you think that you're going to open source also that part?
Wait. The first thing is the open source agent and the SaaS offering that we have the same UI. It's the same thing. It's not a different UI. What Netdata Cloud can do is, instead of collecting all the data, if you go to Datadog, you push all your data to Datadog. We don't do that. So your data are inside your Netdata, inside your servers. What Netdata Cloud does is that it can provide you a unified view by querying all the relevant Netdata. So it queries them, gets the data, aggregates them, and it gives you the same view a parent would give you. Okay? Without having the data. We rely on your agents being alive for this. This is why we have the streaming. So when you have ephemeral service, a Kubernetes cluster, the node may vanish. What you do there is you need a node outside this, outside the Kubernetes cluster, to be a parent for your data. This is where your data will be eventually. This allows you to have very small retention on every server, even disable ML and health checks, etc. Disable them on your production systems, and have a cluster of parents. Parents can be clusters, so you can have 2 or 3 or 4 or how many you want in a chain, so that you can loop them, replicate one to another. And they will find out if something is missing. They will find out by themselves. Okay?
So we have time for another question.
Thank you. I would like to ask you, which issues have you experienced when scaling up on several systems or centralized things? Which issues have you experienced when you scale up to several systems or other centralized things?
So, as with every software, there is a maximum vertical scalability it can sustain. Netdata, as you saw, is better than Prometheus. Actually, we can be almost 2 times in some cases in terms of memory, 1/3 in terms of CPU, etc., etc. But still, there is a cap. The power of the machine you can give to it. Okay? Now, when you need then to scale out, when you need to scale out, what we did is that we split. A query has a number of calculations. It has to do a number of stuff in order to give you this little chart there with the drop-downs and the likes. What we do is that we have the agents do half the work, and then we have a central component that does the rest of the work. So we managed to split the query engine in 2 parts, one that runs at the edge and one that runs centrally. Still there are limits. If you go and put, I don't know, 10,000 Netdata agents in one room and you want one chart with 10,000 queries, you understand it's gonna 10,000 queries are going to happen. So it may take some time. But still what we found out is that the combined power of your infrastructure is better in most of the cases than having a very big server. So even if you query 10,000 servers, there is some latency due to the round-trip delays, etc. But the horsepower that you have, each server will do just a tiny thing. Oh, this is my part, take it. This is my part, take it. But this means that the heavy lift of the query is spread to 10,000 servers. You get it? So it becomes more scalable, faster at the end of the day.
All right. Thank you.